top grades, be exam ready, achieve top grades. Trigonometry Part 3, the grade 7 to 9 challenge. Part 3, extended problem solving. Multi-step 3D, hidden triangles, combined sine cosine rule, and proof. Learning objectives for this session. By the end of this lesson, you will be able to solve multi-step 3D problems, that is, combine several trigonometric steps within a single 3D solid. Next, from hidden right angle triangles, construct auxiliary lines to reveal right angle triangles in complex diagrams. Thirdly, combine the sine and cosine rules. Here we're going to sequence both rules across joined or overlapping triangles. Reason and prove. We're going to use trigonometric relationships and exact values to justify results algebra. Multi-step 3D problems, that's concept number 1. Examinative. Work through 3D problems in stages. Find one length or angle at a time and label each new value on your diagram as you go. And you're going to see me actually doing this. So I'm going to put in labels where I need them. So a square-based pyramid has base 8 centimeters. So, and vertical height is 10 centimeters. To make it clear what I really want to do, I'm actually going to draw the diagram for the 3D shape. So because it's 3D and I'm trying to represent a square, and it will look a bit like a parallelogram. However, we are trying to represent that as a 3D, so I think it looks right. Okay. Now find the length of the sloping edge, and therefore, and also we got to give it to 3 significant figures. So now whenever you do 3D Pythagoras, it would be at least 2 drawings, 2 triangles that you would be looking at in order to find the problem, to solve the problem. So it says we're going to find the length, in that case, and we're going to be drawing our diagram. Okay, so in that case, if we label the sides 10 by 10, 10 by 10, so 10 centimeters, sorry, it's 8 centimeters, not 10. Okay, so let's write 8 centimeters here. Okay, so, and the vertical height is 10 centimeters. So what I'm going to do in the first instance is try to identify the triangle or triangles that will help me solve the problem. Now, in order to find the sloping edge, now I am going to look at this side as the sloping edge. And in order to use that as a sloping edge, so I need to identify the triangle that I'm going to work on. So the triangle for this is going to be that. Now I can call this A, B, B, and C. But I can't find AC as it is, so I would rather extend that to up to point D. And to find AD, then that means I need to look for another triangle, which is going to be drawn in green. Okay, so therefore you're going to have two triangles to work with. Okay, so there's AD, and then I'm going to put another label. So let's call that ADE. To start off, I'm going to use the green triangle. Okay, so the green triangle, which is triangle ADE. I will be using Pythagoras theorem, and you will have spotted that we are working with right angle triangles all the way. So with both triangles, they are both right angle triangles, which means that they would be fit for Pythagoras theorem. Okay, so triangle, going back to triangle AD, so looking for the side AD, so AD squared is going to be A equal to AE squared plus ED squared. So that gives me 8 squared plus 8 squared. So AD is going to be the square root of all this, which is going to be square root of 64 plus 64, which is going to be 2 times 64, and then you're going to get 8 root 2, and that's in centimeters. So that's AD. That now allows me to work out AC. So now AC is part of the triangle ACB. So it's good for you to explain your work carefully because you are going through different stages and the examiners want to know how you're working this through. So now I'm looking at AC. So AC squared is equal to, so AC squared uh, is going to help. AC is half, sorry, is half of AC is half of AD. Half of AD, AD is 8 root 2, which is 4 root 2. So that's length AC we just worked out. Now at this point, it would be good if we could just show that triangle that we're using, ACB, and we have reached the point where we worked out AC, so that's 4 root 2. The height BC is 10 centimeters. Now it is clear from this drawing that AB squared is equal to AC squared plus CB squared. So what is AC? 4 root 2. We're going to square that. CB is 10 squared, and AB is going to be the square root of what we've got just there. Now, okay, so square of 4 is 16. Square of square root cancels out the square root, which leaves us 2. And then we got 100. Okay, so square root of that, and it's going to be 132 square root of that. And the answer is going to be 11.5 centimeters. So this is the sloping edge to 3 significant figures. Okay, that's one done. The next one is a question on cuboid, and the cuboid has base 6 by 8. So we got a base. So let's draw the base. So 6 by 8. So as I said, always draw the bases. In that case, looks like a parallelogram. And then we got it is a cuboid this time. So we're going to replicate that base up here. Okay, and then we're going to connect the corners, the vertices. Okay, so let's just you should have a rubber to actually correct any mistakes. So there you go. We got our cuboid, 6 by 8 by 10. So 6 centimeters by 8 centimeters, and then by 10 centimeters. All right. Okay. So 6 by 8 and by 10. Now, if we want to find the angle between, okay, diagonal, well, the diagonal AG here in that case is meant to be just to picking the right place for me to show you the best position of a diagonal. So yeah, okay, so I spotted that one. Let's call that G. Let's call that A, and so we draw a line to represent the diagonal. Now, if you drop a perpendicular, it goes to AG. Let's call that F. Therefore, we will be looking at triangle, a right angle triangle AFG. And that's one of the triangles. As you know, in 3D, we will have at least two triangles to work on. And let's bring in a green triangle, and that green triangle is actually for the other sides that we have been given. So let's just rub that off and get a proper decent line over here. So that is also going to be 90-degree right angle. Therefore, we need another label to make it clear what we really want to do. So let's call that D. Now, step number one would be to find length AF. All right, and which triangle are we looking at? So that's triangle ADF, triangle ADF. So we're looking for AF, which is going to be AF squared is equal to 6 squared plus 8 squared, and AF is therefore the square root of 6 squared is 36, 8 squared is 64, that's square root of 100, and that leaves me with 10 centimeters. So AF is 10 centimeters, just like GF. Now, okay, on to our second triangle, because at this point we want to find the angle between the diagonal, let's call that theta, and angle between diagonal and the base. So that therefore will involve triangle AGF, and because this is SOHCAHTOA, if you apply SOHCAHTOA, you're going to see that is tan theta is going to be equal to opposite, which is GF over AD. So that's your opposite over the adjacent. Most of the time, when you're looking for the angle, you will be using tan, but that's not a hard and fast rule. But in that case, you got 10, and that you don't need to work out the hypotenuse. Some people do. No reason for that. Okay, so what are we going to do? So that's 10 out of 10 over 10 for tan theta, and theta is tan inverse of 10 over 10, which is tan inverse of 1. And this is a special case, if you know your special angles, that is equal to 45 degrees. Because it says one decimal place, let's add a 0 and put the symbol for the angle, tan 45 degrees. Tan of 45 degrees, or the angle is 45 degrees. So we're now going to move on to, it's time for you to start doing your practice, which would be on the right hand side of that slide. So 2 questions for you to practice, and I'll see you on the next slide with the answers for you to compare with. Okay, so let's move on to the answers. You can pause the video here. Okay, let's move on. So here we are with the answers for the multi-step 3D problems. Hopefully you have explained your work, and it is really important to have structure in your answer and clearly labeled triangles. As you know, we've got 2 triangles to use for 3D Pythagoras, and even for the cone, labels on the drawing are important, and extract your triangle that you want to work with, and also don't forget accuracy is really important. Check the number of decimal places or number of significant figures. Okay, moving on to concept number 2. Now, hidden right-angled triangles. In this case, the examiner tip for us is, if a shape has no obvious right angle, drop a perpendicular from a vertex, meaning a corner of that shape, to the opposite side. Then it splits it into 2 right-angled triangles you can solve. Now, for concept number 2, regardless of what the idea is, always think of drawing a triangle. Well, in that case, it will be triangles, but it will involve triangles. So let's draw the shape. So it says an isosceles triangle has two equal sides of 13 centimeters. So let's start by drawing the isosceles triangle. Doesn't matter, you don't have to have a perfect drawing. It has two equal sides, so those two equal sides will be 13 centimeters each, and a base which is 10 centimeters long. Done. And so find the height and the area of course, of the area of the triangle. Therefore, in that case, we're going to drop a perpendicular from that vertex to the base. So that makes it easy for us because we are working with right angle triangles again. Now, okay, and you can label the corners A, B, C, and then we can have D over here. So what are we looking for then? Find the height. Now, if you want to clarify what you're actually doing, because this is going to now get split into half, and now we're going to get ADB, and this is 13 centimeters long. What we're looking for is the height BD. So using Pythagoras theorem, so BD is one of the shorter sides, so in that case you got to be careful. So AB squared, so AB squared, so that's a B squared is the hypotenuse. Take away the other shorter side, AD squared, and BD therefore is 13 squared. Take away 5 squared. And you know what? I already know the answer. That's going to be 12 because that's a Pythagorean triplet, 5, 12, 13. Okay? And therefore, we know the missing one is going to be 12. So let's find that anyway. Therefore, because you're going to show your work, 169 minus 25, which is the square root of 144, and that is going to give me 12 centimeters as expected. But you know, you're on the right track. Now we got the length BD as 12 centimeters. Therefore, it's going to be easy for us now to work out the area of the triangle. So area of triangle ABC, which is half times base times height, and it's going to be half times 10 times 12, 120, or you can do that, 5 times 12, 60. 60 centimeters squared. Not that difficult. Okay, so but the key idea is to show your work, show your structure. The key idea is actually to drop a perpendicular. Sometimes you can help yourself by just adding a line, a side in the shape that you've been given. Okay, moving on to number 2. Triangle ABC has AB 10 centimeters, B 62 degrees, and BC 7 centimeters. So triangle ABC. So let us draw two lines. So we got, okay, so maybe you got something like that. Okay, we don't know yet. So AB is 10 centimeters long. It's a triangle. And angle B, so angle B is 62 degrees. BC is 7 centimeters. Okay, so let's draw C there. Now find the height of A to BC. So find the height of A to BC. So let's extend that. Okay, depends on your triangle that you have drawn. Now for me, it is the height. This is the height. I'm looking for. So let's call that E. So what we're looking for now is AE. So it would be good to draw the shape of this triangle. So we got AE. So that's 62 degrees, and that's 10 centimeters. So we're looking for AE. Let's call that B. Well, that is B already. So what you're looking for is this side, AE. Now AE, so if you remember your SOHCAHTOA, so we're looking for AE, which is our opposite in that case, and opposite is hypotenuse times the sine of the angle. So the opposite AE is our opposite, which is hypotenuse multiplied by the sine of the angle, sine 62. So 10 sine 62 degrees. Okay, you can leave it like that, or you can work it out from your calculator, which that's going to give you 8.83 centimeters. But you can leave it, you don't need it at this point. This is an intermediate answer. That will lead to the next part, which is find the area of the triangle. So area of triangle. So we're looking for area of triangle ABC, which is base times height over 2. And what's the base? The base is 7 centimeters. And the height is, this is the height, which you worked out. Like I said, you could have just said 10 sine 62, and the whole lot is divided by 2. And when you do the calculation using your calculator, so that should give you 30.9 centimeters squared. Okay, hope that works for you. Dropping a line, so I'm going to highlight the two places where actually I dropped the line. So this is where we did that, and this is where the second question, that's where we drop the line. Okay, that's what the idea was, to drop a perpendicular. Okay, now I will move on. Before I move on, I will let you do some practice question on the right here, which is for you to practice. Okay, and you pause the video for a while you do the practice, and then we move on to the next slide. Okay, so you will see that these two questions required you to draw perpendicular lines, which were there, and there was another perpendicular line here. So hopefully you found that quite easy to do, and we're ready for the next concept now. Concept number 3, combine sine and cosine rule. Here's your examiner tip. In two triangle problems, find every angle and length you can in the first triangle before you move on to the second triangle. A shared side or angle bridges them. Okay then, so let's look at concept 3, where you have to draw two triangles. In triangle ABC, AB is 8 centimeters, BC 10, and the angle ABC. Okay, so let's draw that. So let's say 8 centimeters here. Then along the side, 10 centimeters. So we got A. Now you will notice that B is the one that is common to these two. So that's your clue for drawing your diagram. So B will be right in the middle, and that's a C here, and the angle is 48 degrees. Use cosine rule. Okay, so let's join these two vertices A and C. So it says use cosine rule to find AC, and so in that case it's just one triangle, and then we will look at the second question, which will be the second where we'll have to use the second triangle. So let's combine. Let's use the first one then, cosine rule. So if you remember, for cosine rule, we need to use the lowercase letters. So let's say this is V, that is A, and that is C, because these are opposites. Okay, and therefore we're looking for length B, which is the same as length AC. So B squared will be the other two letters squared and added together, and that's double the two other letters, which are A and C. And we always end up, if we start with B, we will end up with B at the end. Okay, so this is your cosine rule, and we're now going to do the substitutions. Okay, so what is A? 10 squared, then C is 8, so we square that, minus, okay, so anything that I substitute, I put them in brackets. That's keep that habit. So A is 10, B is 8, and then you have cosine of 48 degrees. Okay, so that's going to be 100 plus 64 minus 2 times 6, 160 cos 48 degrees, and that's for just B squared. So B therefore is going to be B. So if you work it out, that's going to be B is equal to AC. So if you do, that's a V squared, and therefore B is, you take the square root of all that. So if you want me to, we can actually change that. We can just put the square root there to make it easy to understand. That's the square root, and that leads us to B as being 7.54 centimeters. There you go. That's the answer for the first question. In triangle ABC, AC is 10 centimeters, angle A is 45, okay, and angle C is 75. So we got two angles and a side in between them. So right, so that is, say, 45 degrees, and then you got a, let's say this is 75 degrees, doesn't have to be to scale. So this is A, angle at A is 45, angle at C is 75, and then you are going to have AC, which is 10 centimeters. Use the sine rule to find BC. Now let's see, we're going to stick to our little lowercase letters. So that's going to be our small a, small b, and small c, and that's going to be, let's call that b then. So that's going to be small b. What we're looking for is BC. BC is small a. Now, how do you small a? So we got to pair up the angle and the side, the angle and the side, and the angle and that side. Now, it looks like we have to work this out, because then you got two known values for a pair. We need to have two known values for a pair. So that's going to be a known value, that's going to be a known value, so that we can work out that and that. Okay, so let's work out the angle at B. So angle B, so B as an angle is going to be 180, take away 45 plus 75, which is going to be, okay, degrees there, 180 minus 120, and that gives us a 60 degrees, angle of 60 degrees, so that is 60 degrees. Okay. Next, what we're going to do is we are going to find length. Now, if you remember, for sine rule, we're going to apply sine rule here. Okay, because we're looking for sides, okay, in that case, it's going to be, we are pairing up angle B and angle A. So let's say A over sine of A plus B over sine of B. So this is the one we're looking for. We already know these ones, angle A, angle B, and we just need a cross multiplication to find B. So what is A? Um, so we're looking for, in fact, we're looking for A, so we cross multiply that. So we're looking for A. A is equal to B sine A over sine B. So what is B? 10. A, angle A is we sine 45, sine 45 divided by sine B, which is sine 60 degrees. Okay, and when you work this out, you should get 8.17 centimeters. So that's for A. I hope you have picked up the idea here. So what we did for question number 1, applying cosine rule, and question 2, we applied sine rule, and yeah, so no problem understanding that, I hope. So let's move on to the actual question on the right hand side for you to be able to practice them. You can pause the video here. I'll see you on the next slide. Okay, so make it clear where you're applying sine rule, cosine rule, and how you're finding a missing angle as well. So if you can see a structure, it makes it easier for you to follow the reasoning. Okay, and concept number 4, trigonometric proof and reasoning. Examiner tip. Show that questions need every algebraic step written out. You got to state the rule you're using before you substitute and simplify fully to the given result. So first of all, it's a show that question. So show that question meaning then the proof needs to agree, we need to agree with what we've been given. So it's a show that question. So what we got to prove here is that the area is actually of the equilateral triangle is the expression that we have been provided with. Now, the best thing to do is to start actually drawing an equilateral triangle. So here's our equilateral triangle. There you go. And length of, so all sides are equal, therefore A, and A. What is missing is actually the corners, the labels. So we're going to put A, B, C. And if you remember in the previous, one of the previous examples we had to do is actually drop a perpendicular line to a base. So therefore we got another point of reference, which is D. In that case, what we're looking for is the area of triangle where we dropped a perpendicular line and we are looking for BD. At this, so we're looking, let us see why we are interested in BD here. So that's B and that's D and that's A. So we are going to use triangle ABD in order to find the length BD. Okay, so this is going to be the height of the triangle. Now BD using Pythagoras theorem. Okay, why am I mentioning that? It is because when we do reasoning questions, we got to justify what we're doing. So Pythagoras theorem is going to be in use here. So BD squared equals the hypotenuse, which is the longest side, AB squared, take away AD squared. So if you take that away, you'll get BD. Okay, so AB squared, which is A squared minus, okay, so AD is actually half of, is midway between A and C, so half of A. So A over 2, so we're going to square that, and remember we are squaring that as well. And that gives us A squared minus, now squaring A is A squared, squaring 2 is 4, and 1 minus a quarter, a squared minus a quarter of a squared gives you 3/4 of a squared. However, if you're looking for BD, you're going to take the square root over that, and you end up with square root of 3 because you can't simplify that. Square root of 4 is 2. Square root of a squared gives you a. Now we got BD. Okay, so BD is the height, if you want, of that triangle. So in order to find the area of the triangle ABC, ABC, you're going to multiply the base with the height and then half that. Or you can say half times base, which is a, and the height is root 3 over 2 times a. So that gives you root 3 a squared over 4. And it's a show that question. So just write, all right, shown, done. Mission accomplished. Question 2. In triangle ABC, prove that if C, one of the angles is 90 degrees. Okay, so the cosine rule simplifies to Pythagoras theorem. All right, so let's draw a right angled triangle because you got your 90 degrees at C. That means if it is a triangle ABC, so A and B will be the other two vertices. And because you were going to start with cosine rule, so let's use the lowercase letters A, C, B, A. And C is the included angle. Therefore, we are looking for C. So we are using cosine rule. So remember, it's a show that question. Therefore, any statement, any rule you are using, you do need to mention them. So we're looking for C. So remember, if we're starting with C, we're going to end up with a big C at the end. So that's going to be a squared plus b squared minus 2ab. And this is a cosine rule, so we're going to use cosine of angle C. Okay, so a squared, we don't need to substitute anything, just use the letters as they are. Now C, you can see C is 90 degrees. So cos of 90 degrees. Now cos of 90 is in fact 0. So the whole term becomes 0. So C squared is the hypotenuse, it's the longest side, and this is the other side added together. So this ends up being the answer, C squared equals to a squared plus b squared. This becomes the resulting equation, and which is the Pythagoras equation, because it's a right angle triangle. So this is therefore confirms that we have got the Pythagoras equation. So this is proved. Okay, so now it's time for you to actually have some practice, and we got the practice question on the right hand side for you. Okay, I'll see you after you pause and practice. I'll see you on the next video, on the next trigonometric proof and reasoning answers, and I think you should have got both answers correct, and we are ready to move on to the next slide. Key takeaways from Trigonometry Part 3, Extended Problem Solving. First of all, multi-step 3D problems are solved one right angle triangle at a time. Label each new value as you find it. Dropping a perpendicular turns an awkward triangle into two right-angled triangles you can solve. In two triangle problems, find everything possible in the first triangle before using the shared side or angle in the second. In proof questions, these require every step of working with the rules stated before it is applied. Coming up in more topics. More grade 8 to 9 series are on the way. Algebraic fractions, circle theorems, and vectors all in the same three-part format. I hope you enjoyed this video. Please like, share, subscribe, and comment. Your feedback will help me create more videos like this. See you in the next video. Thank you. Take care. Bye bye.